Yes, indicating the short circuit current rating on the panel for a Class 1 Division 1 area is required. The National Electrical Code Article 501.10b states that motors, controllers, and motor control centers must be marked with the maximum short circuit current that they can withstand. This requirement applies to all Class 1 Division 1 areas, including industrial control panels. In Class 1 Division 1 areas, there is a high risk of fire or explosion. A short circuit can cause an excessive flow of current, which can overheat equipment and potentially ignite flammable gases or vapors. By marking the panel with its short circuit current rating, personnel can determine if it is suitable for the specific hazardous location. The short circuit current rating must be determined by a qualified professional, such as an electrical engineer. It is typically expressed in kiloamps and should be clearly visible on the panel. The short circuit current rating is essential for safety in hazardous locations. It ensures that electrical equipment can withstand potential short circuit events without causing a fire or explosion. The NEC requires this marking to provide clear information to personnel working in these areas. When selecting an industrial control panel for a Class 1 Division 1 area, it is crucial to verify that the short circuit current rating meets or exceeds the available fault current at the installation location. This ensures that the panel can safely handle any potential short circuit events. The available fault current should be determined through a short circuit study conducted by a qualified electrical engineer. This study will assess the electrical system and determine the maximum current that could flow during a short circuit. The short circuit current rating of the panel should be clearly marked on the panel's nameplate. This allows personnel to easily identify the rating and verify its suitability for the application. It is important to note that the short circuit current rating is not the same as the interrupting rating. The interrupting rating is the maximum current that a circuit breaker or fuse can safely interrupt. The short circuit current rating, on the other hand, is the maximum current that the equipment can withstand without being damaged. When installing an industrial control panel in a Class 1 Division 1 area, it is important to follow all applicable codes and standards. This includes the NEC, as well as any local regulations. Proper installation practices are essential for ensuring the safety of personnel and equipment. Firstly, verify the short circuit current rating of the panel meets or exceeds the available fault current at the installation location. Secondly, ensure the panel is properly grounded to minimize the risk of electrical shock. Thirdly, use explosion-proof conduit and fittings to protect wiring from the hazardous atmosphere. Fourthly, seal all conduit entries to prevent the ingress of flammable gases or vapors. Fifthly, install explosion-proof lighting fixtures to provide adequate illumination. Sixthly, provide adequate ventilation to prevent the accumulation of flammable gases or vapors. Seventhly, implement a regular maintenance program to ensure the equipment is in good working order. Eighthly, train personnel on the hazards of working in Class 1 Division 1 areas. Ninthly, establish emergency procedures in case of a fire or explosion. Tenthly, conduct periodic inspections to verify compliance with safety regulations. The NEC provides detailed requirements for electrical installations in hazardous locations. These requirements are designed to minimize the risk of fire or explosion. It is important to consult the NEC and other applicable standards to ensure that all installations are in compliance. The short circuit current rating is just one aspect of electrical safety in hazardous locations. Other important considerations include grounding, bonding, overcurrent protection, and wiring methods. By addressing all of these aspects, it is possible to create a safe and reliable electrical system in a Class 1 Division 1 area. The selection of appropriate electrical equipment for hazardous locations is critical for safety. All equipment must be specifically designed and approved for use in the specific hazardous environment. This includes explosion-proof enclosures, intrinsically safe circuits, and other specialized equipment. Explosion-proof enclosures are designed to contain any internal explosion without igniting the surrounding atmosphere. Intrinsically safe circuits are designed to limit the amount of energy available to ignite flammable gases or vapors. Other specialized equipment may be required depending on the specific application. The NEC provides guidance on the selection of appropriate electrical equipment for hazardous locations. It is important to consult the NEC and other applicable standards to ensure that all equipment is properly selected and installed. The short-circuit current rating is a critical parameter for electrical equipment in hazardous locations. It helps to ensure that the equipment can safely withstand potential short-circuit events without causing a fire or explosion. By following the NEC and other applicable standards, it is possible to create a safe and reliable electrical system in a Class 1 Division 1 area. Remember to always consult with a qualified electrical engineer or other expert for specific guidance on electrical installations in hazardous locations. Their expertise can help to ensure that all installations are in compliance with applicable codes and standards. It is vital to understand that working with electrical equipment in hazardous locations requires specialized knowledge and training. Only qualified personnel should perform electrical work in these areas. By taking the necessary precautions, it is possible to minimize the risk of fire or explosion and ensure the safety of personnel and equipment. Ensuring electrical safety in Class 1 Division 1 areas involves a multi-layered approach. This approach includes proper design, installation, maintenance, and training. Each of these layers contributes to the overall safety of the electrical system. Proper design involves selecting the appropriate electrical equipment and designing the system to meet the specific requirements of the hazardous location. Proper installation involves following all applicable codes and standards, as well as using appropriate installation practices. Proper maintenance involves regularly inspecting and testing the equipment to ensure it is in good working order. Proper training involves providing personnel with the knowledge and skills necessary to work safely in hazardous locations. By implementing a comprehensive safety program, it is possible to minimize the risk of fire or explosion and ensure the safety of personnel and equipment in Class 1 Division 1 areas. The NEC is a comprehensive document that provides guidance on electrical installations in a wide range of environments, including hazardous locations. It is important to consult the NEC and other applicable standards to ensure that all installations are in compliance. The NEC is updated regularly to reflect changes in technology and safety practices. It is important to stay up to date with the latest edition of the NEC to ensure that all installations are in compliance. The NEC is not a substitute for engineering judgment. It is important to consult with a qualified electrical engineer or other expert for specific guidance on electrical installations. Electrical safety in hazardous locations is a complex and challenging topic. It requires specialized knowledge and training. By taking the necessary precautions, it is possible to minimize the risk of fire or explosion and ensure the safety of personnel and equipment. The short-circuit current rating is a fundamental aspect of electrical safety in Class 1 Division 1 areas. It is essential to understand this concept and to apply it correctly to ensure the safe operation of electrical equipment in these hazardous environments. Always prioritize safety when working with electrical equipment, especially in hazardous locations. Adherence to established codes, standards, and best practices is crucial for preventing accidents and ensuring the well-being of personnel and the protection of property.